Let's understand the Flexbox. In order to do so, we first create 3 divs having the name container1, container2 and container3. 2 and 3, like that. Now we create a width and a height for each of those containers. Let's say 100 pixels of width, 100 pixels of height. Now we copy those values. We'll have a background color of yellow. And now we copy the container 1 and make the same for container 2 and container 3. We just choose a slightly different color for both of these containers to see a difference. So now we have those 3 containers basically. And as you can see, each div takes up the entire space of one row. So what if we wanted to have those divs next to each other? Obviously, we could use inline block, but that is definitely not something you want to do when you have the option to use a Flexbox. And in order to use a Flexbox, you need to wrap all of those divs with a parent element. And now we can give that parent element a class of, for example, parent container. Just make it clear. Now we copy this class parent container and create a selector for that class. And now we want to say inside of this parent element, I have 3 different divs. And inside of this parent element, I want to have all 3 divs next to each other. That's what we're basically saying. And in order to do so, we can use display, and we can set display, as already mentioned, to block, block, or inline. But we can also say that we want to have display of flex. And by setting display to flex, we are basically saying take every element inside of our parent container. So take every element that is inside of this div, every direct child basically, and place that direct child next to each other. Another thing that is really nice about that is that we can basically also use the parent element to define the spacing of the child elements. So let's basically say we want to have all of those elements in the middle of our page. We can now use justify content of center and center our elements. We could also use align items to center, and we give our container, our parent container, of height of 100 viewport height basically. So the container takes up the entire space, and justify content basically says justify the content to the center, and align item says align the content to the center. And in this scenario, align items basically refers to the vertical axis. So align the items on the vertical axis in the center. So basically in this axis. Justify content right here refers to the horizontal axis. So basically it refers to the row. So we basically use justify content to center along the row and align items to center along the column. But in order to understand how this really works, we need to flex direction, and the default value for flex direction is row. So flex direction row basically means take all of the content inside of the container and arrange it in a row, the way we did it right here. And now let me draw something for you so you really understand it. If our flex direction is set to row, it basically means that we have a main axis and a secondary axis. And since flex direction is row, our main axis, which we indicate by using M, is our row. And our secondary axis is basically our column, like this. Now there's a second type for flex direction, and that second type is column basically. So if we set the flex direction to column, for example, you'll see that our content is now arranged in a column. The primary axis is now the column, and the secondary axis is now our row. So this column is the primary axis now, while this row is the secondary axis right now. So what is the difference basically? Now the content is arranged from top to bottom, while it was previously arranged from left to right. That's obviously the first difference, but the flex direction also changes the way our justify content and align items property work. So let me show you. Let's set flex direction to row again, and let's remove align items again. Now if we set our justify content to center, justify content always refers to the primary axis. And since flex direction is row right now, our primary axis is the row. So justify content basically says along our row, justify our content in the middle, so in the center. So if we change our flex direction to column right now, our column row, so basically our column, becomes our primary axis, and justify content always refers to the primary axis. So justify content now says, take our primary axis and align the content in the center along the primary axis, which is the column right now. So once I save this, you can see our content is now centered along the primary axis, which is now the column. So our content is centered along the column. And now if I would use align items always refers to the secondary axis, and our secondary axis, since we use flex direction of column right now, is our row. So align items will now say, if I set it to center the content along the secondary axis, which is our row right now. So I save, and our content will go to the middle of the row right now. So it's really important to understand that flex direction does not only change the direction the Flexbox basically arranges our content along, but it also changes the way justify content and align items work. And again, justify content always refers to the primary axis, while align items always refers to the secondary axis. And by default, if you don't use flex direction, the primary axis is usually the row. So obviously justify content can not only be set to center, but you can also say that we want to have some space around, some space between, or space evenly. So if I say I want to have some space around the content, it will have some space around every single box. Now I could obviously also say I want to have space between the content, and the difference is that it will have space between the content but not around the content, so there won't be any space to the left and to the right basically. Now you could obviously also say that we want to go with flex start, for example, and now our content is arranged to the left, so basically arranged to the start of the Flexbox. And we can also use flex end, for example, and now we go to the end of the Flexbox and we'll arrange our content right there. It works pretty similar for align items, so we could, for example, say align items, center, flex start, flex end, and so on. So we could, for example, say let's go to flex start basically, and we basically go to the start of the Flexbox along the secondary axis, which is our column right now. We could obviously also say, okay, let's go to flex end, and we'll arrange our content to the end of our Flexbox. Let's first of all go back to center because it looks a little bit better. And now let's say we want to have a gap in between of the items. So we could use the gap property for that circumstance. And we could say, okay, let's have a gap between every single item of 30 pixels. And now you have a gap between those items of 30 pixels. Now we could obviously also say, okay, we want to have 50 pixels. For this instance, let's say the width of our items is a little bit more and the height is a little bit more. So our items are getting a little bit bigger. Once we save, we basically have this box, if you want to say it like that. And let's also probably create a fourth container with a background color of, yeah, something like that. And we obviously also need to create that container in our HTML file, so we are going to do so. And as you can see, now our boxes basically get smaller. And in order to do so, we can also define inside of the parent container again how our Flexbox should basically behave. And in order to do so, we can use the flex wrap property. And the default is basically no wrap, which means no matter what happens, even if the content gets squished like here, don't wrap. And the alternative is basically wrap or wrap reverse. You're just going to use it, and once you activate wrap, basically the content is basically going to wrap into a new row. You can obviously also use wrap reverse, which will just reverse the order of the wrapping basically. But most of the times you just want to use wrap to wrap into a new row. So now let me explain some important concepts. So first of all, let's take a look at the structure again. We have basically those 4 containers, and we have a parent container. Those 4 containers are inside of the parent container, and previously all we did basically happened to the parent container. So we activated display flex in the parent container, we justify the content inside of the parent container, we line the items inside of the parent container. But there's also a way to define for every single element how the element should behave once the amount of space basically changes that every element has, that is basically available to every single element. And that is something you can change for every single element. So we are not going to define that property for the container, but rather for every single element. And the first thing we can basically do is set a flex basis of 100 pixels, for example, and a height of 100 pixels as well. So flex basis in this case defines the width of our element, because our flex direction right now is basically row. If we would change our flex direction to column, it would define the height of the element. So flex basis basically always changes the value along the main axis, which is the row in our case. So we can use flex basis instead of width, while we can use height for the height. So let's use a flex basis of 100 pixels for every single element. Like that. So now we have all of those elements next to each other again. Let's change the gap to probably 10 pixels. But as you can see, there is a lot of available space right here. So couldn't we maybe say that we want container 1 to probably grow as much as he basically can if there's available space? And we could actually do so by using the flex grow property and setting that one to 1. And as you can see, our first container is now taking up all of the available space. Now let's say I want our blue container to grow as well. So I could go ahead and set flex grow for our blue container to 1 as well. And as you can see, our yellow and our blue container now grow and take up all of the available space if there is available space. But maybe we want our container 1, so our yellow container, to grow slightly more than our blue container. So we could, for example, say flex grow is 2 for yellow and 1 for blue. So blue will take up some available space, but yellow will take up a lot more of the available space. And we could obviously also say like 4. So now yellow will take up even more of the available space, while blue will take up a lot less of the available space. And obviously we could also go ahead and set flex grow for the green container, for example, and so on. So this is how you basically define how the element works when there is space available. And the default value for flex grow is 0, which means you don't grow. So if we set yellow to 0, for example, it means just take up the space that flex space is defined and don't take any more space. So we want to have 4 in our circumstance, for example. So now there's also a flex shrink property, and its value is 1 by default. So if we do that, nothing is actually going to change. But let's say that we have a shrink value of 3, for example. And let's say we have a shrink value for the blue box of 2, for example. Now our yellow and our blue box will shrink a lot more. So let's take a look. If I make the window a little bit smaller, you can see our blue box shrinked a little bit, while our yellow box shrinked a lot. Now for flex basis, flex grow and flex shrink, you also have a shortcut property, which is basically just flex. And for flex, the first value is basically the grow factor, the second one is the shrink factor, and the third value is the basis. So basically grow, shrink, basis, like this. So let's remove flex grow, flex shrink, and flex basis. And let's say we want to have a grow factor of 5, for example. So we want this one to grow a lot. Now let's say we have a shrink factor of 0, for example. So it's not going to shrink at all. And then let's say we have a basis of 100, or let's say we have a basis of 100 pixels. And that is basically the basis, is basically the point where the element would start to shrink. So if there's space available, it will take up all of the available space basically, or a lot of the available space. It will basically not shrink once it hits 100 pixels. So it will, if you want to say it, shrink up to 100 pixels, because that is basically all the space that it just takes up because of flex grow. But once it reaches this basis, it is not going to shrink because we have a shrink factor of 0. So let's take a look at that. Now I'm going to make the window a little bit smaller, and it will shrink down to 100 pixels basically, and now it will not shrink anymore. Also, let me remove flex wrapped for this test, and now we'll basically take the window, we make it smaller, we make it smaller, we make it smaller, and at a certain point, once it reaches 100 pixels, it's not going to get smaller anymore. And we could also like say, okay, let our green container have a width of, for example, 300 pixels, which makes it a little more obvious. So now the yellow container is basically taking up a lot of space when there's space available, and once you shrink, it basically shrinks down to 100 pixels. And at a certain point, you can see our blue item is really shrinking a lot because we have like a flex shrink factor of 2, but our yellow item is not shrinking at all anymore because we have a flex shrink factor of 0. Like, I hope that is understandable. We could obviously also do the same for the other containers by just using the flex property. So we could basically say flex, and now we want to have a flex grow factor of 1, a flex shrink factor of 2, and a flex basis of 100 pixels basically. And by doing so, we could remove flex shrink, flex basis, and flex grow. I know that the Flexbox is a complex topic for a lot of beginners, but I really hope you understood everything, and that is all you need to know about the Flexbox in CSS.